Isolated parallel plate capacitor of capacitance C, the force specified charge is Q1, Q2 और ये. The potential difference between the plates is seriously. Okay, so क्या यहाँ पे Q1, okay fine, just you know. Wait, capacitance में C दिया हुआ है. Okay, so what is the capacitance like? अगर charge Q negative Q रहता है, it's like just Q upon A epsilon naught. Or yeah, it's like A epsilon naught. That is the field in that case, and in terms of D, right? That's our voltage. So just want Q upon V. So अपना जो C रहेगा, or like 1 upon C basically. 1 upon C equal to D upon A epsilon naught, right? So ये जो चीज है, it will cause field of what? It will cause field of 1 upon C times D. And okay, we just want the potential difference anyway. So ठीक है, उसका potential difference. So like क्या आ जाएगा? In this case, just have D upon 2A epsilon naught हर जगह पे आने वाला है. And then first of all, just have Q1 supporting. Then you have Q2 supporting. You have Q3 retarding, and then Q4 retarding. Right? That's a potential difference or drop or whatever. Magnitude of this thing basically. Right? So there's a mod लेना है in any case. Right. Yeah. So like maybe D is correct. Actually नहीं यहाँ पे 2 चाहिए ना. Right. So this should actually be. But it's like upon that actually makes sense. So ये जो चीज है, it's like this. 1 upon 2C times ये सब, या मुझे 1 upon 2C चाहिए रहेगा. Isolated parallel plate capacitor of capacitance C, the four surfaces have charge, this, the potential difference. Oh, and also, right, because it's isolated, you know कि, right, okay, cool, understood. तो इसमें फील्ड 0 हो जाएगी, which means like Q1 is equal to Q2 plus Q3 plus Q4, and then ये जो चीज है Q4 is equal to that, right? So Q1 minus Q3, wait, ये क्या है? Q2 है ना पहले, okay. Minus Q2 minus Q3 minus Q4 equal to 0, and then क्या हो जाएगा? Q1 plus Q2 plus Q3 minus Q4 equal to 0. मतलब कि subtract करता तो what you get like Q2 plus Q3 equal to 0. So Q ये जो है वो negative हो जाएगी. जैसे कि basically like Q2 is right equal to negative Q3 और Q3 equal to negative Q2. तो फिर ये जो चीज है, this is just equal to 2 Q2 over there plus 2 Q2. But then similarly तुम बोल सकते हो कि so Q2 plus Q3 तो 0 हो गया, like Q1 is equal to Q4 in that case. तो ये तो मर गया in that case. Oh, बढ़िया. So this is the thing. यहाँ पे 2 Q2 आ जाएगा, and then this just becomes Q2 upon C or like mod Q2 upon C. So B would be the answer. तुमने Q1 Q2 Q3 Q4 दिए नहीं है, like yeah, and that's why I'm gonna assume कि वो ऐसे configuration में. Yeah, this is the thing. So this is wrong. It's just Q2 upon C. That's right. So D is the answer. Next question. Okay, 72. 72 is in a parallel plate capacitor of plate area A. Separation between plate separation क्या? I think D चाहिए यहाँ पे, जो separation D and charge Q, force of attraction between the plates is F. Right. So what is F? I mean, F is proportional to Q square for sure, because yeah, so right, you know the thing. It's like Q upon A epsilon naught, and so Q upon A epsilon naught or 2A. This is that field. That times इसका जो charge रहेगा just Q square in that case, right? This thing is our force. फर्क नहीं पड़ता D क्या है. So F is proportional to Q square and 1 upon A. नहीं, C is wrong, D is wrong. So A and B are correct. Next question. Next is 73. Okay, cool. The capacitance of a parallel plate capacitor is C naught when the region between the plates has air. This is now filled with dielectric slab of K. The capacitance now is connected to a cell of EMF E. The slab is taken out. अच्छा, slab is now taken out. Okay, cool. Something charge flows through the cell. अच्छा, पहले क्या था? So पहले तुम्हारा potential, let's just say V potential है, right? Okay. So पहले तुम्हारा just V potential difference. What's the capacitance? Initially C naught था, अब तुम्हारे पास में K C naught हो जाएगा, right? Okay, so like K C naught V, that was the initial charge. अब कितना है? अब है just K C naught. So जितना charge flow हुआ है, this is K C naught times sorry, इसको K नहीं आएगा. It is C naught V. So K minus 1 C naught V, that is the charge that flew whatever. तो इतना charge था through the cell, right? Yeah. So this charge flows through the cell. Yes, so A is correct. और क्या है? Energy होगा absorbed by the cell. But okay, so इसकी एनर्जी कैसे चेंज हुई? It's like half C V square होता है, so just half K C naught V square से चेंज हुआ to half C naught V square, right? So तुम्हारा जो एनर्जी चेंज हुआ is like half K minus 1 C naught V square. I should say gives energy change, but like whatever. और फिर ये जो चीज है सेल से जितना चार्ज फ्लो हुआ दैट वाज जस्ट के माइनस वन, हाँ वो चीज। सो उसने जो वर्क किया के माइनस वन सी नॉट, दिस इज लाइक व्हाट राइट, तुम्हारा यहाँ पे इनफैक्ट डिक्रीज हुआ, तो एक्चुअल में द एनर्जी चेंज इज लाइक दिस नेगेटिव ऑब्वियसली, राइट। और उतना फ्लो हुआ थ्रू दैट, so तुम्हें yeah right, like 1 minus k, okay, that much of charge you had to give, so work किया cell ने it's actually like this times v, uh, जो भी है, this is the energy consumed by the, right, and the work done by this thing is just negative of k minus 1 c naught v squared, right। तो बाकी का सारा कहाँ पे गया वर्क, बाकी जितना वर्क था दैट वाज जस्ट नेगेटिव वन अपॉन टू के माइनस वन सी स्क्वायर सी नॉट वी स्क्वायर। ये जो वर्क है वो कहाँ पे गया, राइट। एक्चुअली ये वर्क है नहीं, ये नेगेटिव है, सो लाइक हाफ के माइनस वन सी नॉट वी स्क्वायर वर्क हुआ सेल पे एक्स्ट्रा, तो वो उसने एब्जॉर्व कर दिया होगा। सो या so the energy stored in the capacitor is reduced by this thing, no, the energy, the external okay agent has to do this much amount of work to take the slab out, well that explains it, yeah, yes that actually does explain it, so D looks correct, right, because हाँ अपन assume कर रहे हैं कि जो cell ने work है is like just equal to Q times of V, or yeah that is the thing, the work done by the cell, yeah that is the thing, so हाँ the energy lost by the cell or absorbed by the cell is in fact ये चीज, that is right, so B is correct and D is also correct, so अपने को work करना पड़ेगा, yeah of course, so external agent has to do this amount of work to take the slab out because slab consumes some energy, right, मतलब उसकी एनर्जी क्या होगी, इसमें डिक्रीज हो गई, राइट, व्हाट, हाँ तो उसने एनर्जी लाइक ओके स्लैब ने खुद, राइट, तो कैपेसिटर से खुद एनर्जी गई सेल में एंड ऑल्सो अपन ने भी एनर्जी दी थ्रू कैपेसिटर टू सेल बेसिकली, विच इज दिस मच, yes, so D is correct, B is correct, and A is correct. So A, B, and D. Next question, 74. You know what? Like using this thing, you should even figure out the force required to pull that. वो जो भी है, just move on. Okay, a parallel plate parallel plate air capacitor of capacitance C naught is connected to a cell of EMF E, and then disconnected from it. Air capacitor. Okay, cool. A direct slab of okay, which can just fill the air gap on the capacitor. Potential difference between the plates decrease k times. Yeah, right. So it does decrease because field जो है is like now 1 upon k. So yes. So A is correct because it's a wait. EMF E पे तुमने okay पहले तुमने कनेक्ट किया सेल को and then disconnect from it. Ah right. So अब सेल का इसमें कुछ importance है. फिर तुमने स्लैब इसमें insert किया है. Right. This can just fill the gap of the capacitor. Okay. So तुम्हारा charge है that remains the same. Okay. So yes, A is correct. बिकॉज तुम्हारी फील्ड ओरिजिनली हाँ वो सेम रहेगी, तो एनर्जी स्टोर्ड इन द कैपेसिटर डिक्रीजेस k टाइम्स। सो इस केस में क्या होगा, लाइक जनरली हाफ सी वी स्क्वायर रहता है, लाइक सी वी जस्ट क्यू एंड देन वी इज क्यू अपॉन सी, सो इट्स लाइक क्यू स्क्वायर्ड अपॉन टू सी भी अपन बोल सकते हैं, क्यू रिमेन्स द सेम, राइट, मीन क्यू रिमेन्स द सेम थिंग एज सी नॉट ई, सो लाइक सी नॉट स्क्वायर्ड एंड देन ई स्क्वायर्ड, फिर वी स्क्वायर में यूज करूंगा अपॉन टू, ये तो फैक्टर बाहर ही आ जाएगा, एंड देन हमारा जो चेंज हुआ, सो अब जो नया कैपेसिटेंस इज लाइक 1 अपॉन के सी नॉट, और जो पुराना कैपेसिटेंस था इज लाइक 1 माइनस yeah just C naught over there, right, well yeah that's the energy का change जो इसमें हुआ, which is so it's like 1 upon k minus 1 times C naught V squared upon 2, right, that's the change in energy of our capacitance। तो और ये जो चीज है like positive, तो इतनी energy in fact insert करनी पड़ी, right, the potential difference between the plates is about k times, energy stored in the capacitor decreases k times, yeah because नई जो energy is just this thing like 1 upon k of previous one, understood। The change in energy is half C naught e squared k minus 1, no, change in energy is this thing, not 1 minus 1 upon k, that's not the thing, should be 1 upon k minus 1 I think, right, energy increase हुई ना अभी तो, because energy increase हुई ना अभी तो कि नहीं, half c squared q squared upon 2c बोल सकते हैं, so q thing is a c naught squared b squared, फिर ये upon 2 निकल गया, just 1 upon c. Right, that has to be things. हमारा q सेम रहेगा, so it has to be this thing. Energy changes है. So like अब energy थी, okay, 1 upon k. Wait, k is what? Is this bigger than 1 or less than 1? I think k is probably less. It's like bigger than 1. In that case, ये जो चीज़ है, it's actually negative. Then yeah, change in energy is this thing. Okay. Uh, right. So the energy stored in capacitor decreases k times. Maybe तुम ऐसा बोल सकते हो. So like it's k is bigger than 1. So B is correct. Potential difference between the plates decreases k times. It's just q upon c होता है, and then c now became k times. So yes, it does decrease k time. A सही है, B सही है. Change in energy is this thing. Yeah, so D is also correct. So A, B, and D. Next question. 75. 75 is a straight conductor AB lies along the axis of a hollow metal cylinder L, which is connected to Earth through a conductor C. The quantity of charge will flow through C. Okay, straight conductor AB lies along the axis of a hollow metal cylinder L. Metal cylinder connected to the Earth through a conductor C. And straight conductor AB. Oh, it's like a hollow cylinder. Okay, cool. Quantity of charge will flow through C. C से flow होगा. Okay. If current begins to flow through AB, then there's like a magnetic field over here. Okay. But that's not changing. Is it changing? Probably it is changing. Then ठीक है ना, अगर change हो रही है, then that will cause. Oof, this is weird. The current through AB is reversed. Yeah, because ये cylinder जो है, that's not the way that it's usually done. Okay. नहीं, तुम्हारा फ्लक्स रहेगा थ्रू दैट. जैसे एक उसमें का सर्कल लो, वो जो एरिया रहेगा, लाइक या सो एरिया लिमिट्स लाइक परपेंडिकुलर टू द मैग्नेटिक फील्ड ऑल द टाइम. तो फ्लक्स मेरा जीरो हो गया. ओह, देन क्वाइट लिटरली देयर इज लाइक नो ईएमएफ इन दैट सर्कल. ओह राइट. तो फिर सिमिलरली, ओह ओके, दिस इज वेरी वियर्ड, बट कोई और सर्कल बात करते हैं. ओह राइट, यू कैन ऑल्सो थिंक अबाउट दिस सर्कल. सो उसमें ईएमएफ कुछ नहीं है, बट देन देयर इज ईएमएफ. ऐसे अगर अपनी रेक्टेंगल टाइप उसको भी लेते हैं, देन लाइक उसके जो थ्रू फ्लक्स जा रहा है, इट्स लाइक ओके थिंक हमारी एक वायर है, ये तुम्हारा एरिया है, इसके थ्रू कितना फ्लक्स जा रहा होगा बिकॉज ऑफ द मैग्नेटिक फील्ड. राइट, थिंक अबाउट इट. क्या वो फ्लक्स पॉजिटिव है, नेगेटिव है? व्हाट यू इवन से अबाउट दिस? थिंक थिंक थिंक. हाउ डू यू डू दिस? हाउ डू यू डू दिस? गॉस लॉ का इक्विवेलेंट तो अपने पास में है नहीं यहाँ पे, अनफॉर्चुनेटली. व्हाट डू वी डू? देयर इज डेफिनेटली फ्लक्स थ्रू इट. ऐसे कुछ रीजन्स में हो सकता है, बट देन दिस इज एक्चुअली एक इसमें फील्ड ऐसे जा रही है, एक से फील्ड ऐसे जा रही है. सो आई गेस दैट वो फ्लक्स कैंसिल हो जाएगा, राइट? या टेंजेंशियल कंपोनेंट वी डोंट एक्चुअली केयर अबाउट दैट. लाइक नॉर्मल कंपोनेंट तो कैंसिल हो गया बिकॉज ऑफ सिमेट्री. दैट मीन्स कि फ्लक्स इज जीरो थ्रू एनी ऑफ दी सर्फेसेस. मतलब कि ओह, दैट जस्ट मीन्स कि कोई फर्क नहीं पड़ रहा कंडक्टर पे. ओके, so if AB is removed and a beam of electrons, okay, so if a current begins to flow through AB, कुछ भी नहीं होगा. If a current through AB is reversed, नहीं, कुछ भी चेंज नहीं होगा. That's what I'm saying. AB is removed and a beam of electrons floats space. So यहाँ पे कुछ भी चार्ज उन्होंने डाल दिया है. Because of that charge, right, that will actually cause a field normal to it. तो मतलब कि वहां से right, because of that यहाँ पे shielding होगा. That will cause flow of charge, right? That actually does explain it. So yes, and a beam of electrons flows in its place. Yes, so C is correct. If AB is removed and a beam of protons, once again the same idea. So C is correct, D is correct. 75 का C and D. Next, it's not the magnetic field that matters, it's the electric field. 76. The charge flowing in a conductor varies with time as A equal to blah blah. Then the current, okay, flowing in a conductor. What do you mean by that? Charge deposited, understood, but then flowing in the conductor? The current decreases linearly with time, falls to zero after. I mean, I get it. It's just dq upon dt, but then I guess क्रॉस सेक्शन से कितना करंट अभी तक पास कितना चार्ज अब तक पास हुआ है, that's what you're talking about. Then it is negative, right? So a minus 2 bt, that's our current. Decreases linearly time, yes. Falls to 0 after t equal to a upon 2p. No, ऐसा नहीं होता है. It is a maximum and then decreases. Because a minus 2, it's a linear function. नहीं, ऐसा नहीं होता है. Changes at rate minus 2b. So d is correct, a is correct. 77. Okay, this thing. When some potential difference is maintained between A and B, current I enters the network at A and leaves at B. Okay, करना है कि अपने equivalent resistance between A and B is 8 ohms. अच्छा ढूंढना है क्या है? Let's just see T over there. Yes, में current. Oh, it's like the same. Oh, it's like wire. तो same potential हो जाएगा. It's like इसको separate कर डालो. Right. So it's just 1 upon 20 plus 1 upon 5. Multiply by 20, I guess 20 upon 1 plus 4. So 5, which means like 4. Here plus same thing. So yeah, it's just 8. 8 is the resistance. Yes, so A is correct. और क्या है? So you know, C and D are the same potential. Yes, P is also correct. No current flows between C and D. That's wrong. That's not the thing. There does, right? है इसमें current flow होता है. Same potential इसका ये मतलब नहीं कि current flow नहीं होगा because यहाँ पर resistance ही 0 है. So yeah. So D, C is not correct already. Current something flows from D to C. सब अपन निकाल चुके हैं ना कितना करंट है. चल करंट तो निकाला बट लाइक रेजिस्टेंस अपन निकाल चुके हैं. जो भी है, think about it. What's the current है, you'll have to like split it basically in, right, so V equal to I R is तुम्हारा जो voltage है that will be the same, so the current is proportional to 1 upon R. Is 4 to 1, मतलब कि यहाँ पे 1 is to 4 आएगा, क्योंकि यहाँ पे 4 times, यहाँ पे 1 times, it's just 4/5 I here and 1/5 I over there. फिर यहाँ पे 4/5 I और यहाँ पे 1/5 I, मतलब कि it's like current flowing through that. यहाँ का 4/5 का 1/5 हो गया किस तो भी करके, which means कि 3/5 I is flowing in this direction. Yeah, so D to C 3/5 I जा रहा है. So D is also correct. Right, next question. 78. 78 is this thing. Okay, in the circuit shown, the cell is ideal with EMF equal to 15 volts. Each resistance is of 3 ohms. The potential difference across the resistance capacitor is, कौन सा कैपेसिटर, मुझे तो कोई दिख नहीं रहा है. This is a wire, this is a wire. हाँ, सेल इज आइडियल. कौन सा सेल, क्या बोल रहे हो लोग? EMF equal to 15 volts. Each resistance of 3 ohms. ये इससे मैच नहीं हो रहा है. The potential difference across capacitors, I don't know, it's not matching with the figure. ये क्या है? This does not match with this at all. कौन सा सेल नहीं है? रेजिस्टेंस पता नहीं कहाँ पे क्या बात कर रहे हैं. पोटेंशियल डिफरेंस अक्रॉस कैपेसिटर, कौन सा कैपेसिटर यार? सो ये मिसमैच हुआ फिगर का. आई डोंट नो उसका कैसे करता हूँ. 79. In the circuit shown, the cell is ideal with EMF equal to 2 volts. Okay, ये मैच हो रहा है. Resistance of the coil of the galvanometer 78, right? So 77, 78. Yeah, that's the thing. Okay, whatever. Cell is ideal, EMF equal to 2 volts. EMF equal to 2 volts. Okay, resistance of the coil of galvanometer is 1 ohms. What do you want? No current flows in G. So you want just initially कि क्या? यहाँ पर ऑलरेडी चार्ज किए हुए, कुछ तो मुझे बताओ यार. ओके, सो इनिशियली फिर लाइक ओके इनकी पोटेंशियल सेम हो जाएगी बिकॉज देयर इज नो चार्ज थ्रू इट. मतलब कि यहाँ पे सेम पोटेंशियल हो गया, ये सेम पोटेंशियल हो गया, राइट, व्हिच मींस there's only current flowing through this thing in that case. Oh, understood. So basically like वो वायर जैसे हो चुके हैं, राइट. सो ये ऐसा है, यहाँ पे 4 है, दिस कैलोमीटर इज लाइक 1 ohms. ये वायर है, वंस अगेन दिस इज 4 ohms. तुम इससे कनेक्टेड क्या क्या देख रहे हो तुम, ये 2 पॉइंट्स, राइट. तो एक काम करो, इसको हटा दो, लाइक टू दिस थिंग एंड सिमिलरली टू दिस थिंग ओवर देयर. और यू कुड ऑल्सो डू दिस थिंग कि ये इसको ऐसा कर डालो एंड देन डू इट लाइक दिस, क्योंकि ये सेम ही पोटेंशियल होना है ना. थ्रू आउट दिस वायर इज द सेम पोटेंशियल, सो यू कैन जस्ट डू दिस, और कहीं से भी करंट कंडक्ट करो, सेम चीज होगी. सो और एक काम करो, इन 4 को पूरे लाइक पैरेलल ऑफ कोर्स, राइट. 3 ब्रांचेस है इसमें, राइट. तो ये करंट या यहाँ से निकल सकता है, यहाँ से निकल सकता है, यहाँ से निकल सकता है, एंड देन तीनों ब्रांचेस एक ही जगह पे डिपॉजिट कर रहे हैं. सो इट्स लाइक पैरेलल, राइट. व्हाट यू वांट? नो करंट फ्लोज इन जी. इट डज फ्लो. पोटेंशियल डिफरेंस अक्रॉस C1, कहाँ पे C1, अबे जीरो होगा ना, अगर हमने इनिशियली स्टार्ट किया then got be zero I guess. Wait. um, अपन इनिशियली बात कर रहे हैं कि फाइनली बात कर रहे हैं, कुछ तो मुझे बताओ यार. कंडीशन डिफरेंस अक्रॉस सी वन. ओके आई थिंक वो फाइनली बात कर रहे हैं, राइट. ओके इन दैट केस कैपेसिटेंस से कोई करंट नहीं फ्लो होने वाला है, इट्स जस्ट रेजिस्ट. ओके जस्ट सीरीज. सो 4 प्लस 5 प्लस 1 राइट 10. तो 0.2 करंट फ्लो हो रहा है इसमें से, सो 0.8 इसमें आया, फिर इसमें आ गया 0.1. once again it's like fine, just 1 वोल्ट का डिफरेंस इन बोथ ऑफ दीज. नहीं नॉट बोथ ऑफ दीज बिकॉज इसमें तो अलग हो रहा है. इसमें 5 प्लस 1 like 6 6 and 1.2, so 1.2 potential difference in C2. So D is correct and C1 में 1 volts. Okay, no current flows in G, that's wrong. 0.2 ampere current flows in G, so B is correct, C is correct, D is correct. You should have told me कि ये steady state की बात कर रहे हो तुम. Anyway, 80. ये चीज़ है. In the potentiometer arrangement, the driving cell has EMF E, internal resistance R. Okay, the cell C whose EMF is measured, इसका EMF को measure करना है. Has EMF, wait what? ने ऑलरेडी दे दिया मुझे. EMF E upon 2, internal resistance 2R. The potentiometer wire is 100 centimeter long. Measure, but तुमने ऑलरेडी दे दिया. Okay. The potentiometer wire is 100 centimeter long, 1 meter. The balance is obtained at length AG equal to L. Okay, लेंथ चाहिए अपने को L. करना क्या है? L equal to what? L. Okay, fine, fine, fine. तो इसका पोटेंशियल क्या है? E इसका है E upon 2 and 2R over there, right? Well, yeah. So जो इसमें से जो करंट फ्लो होने वाला है, like that is completely on. Wait a second. अगर कैलेंडर से कोई अपन करंट फ्लो नहीं करवा रहे, दैट मीन्स कि ये रेजिस्टेंस जो है दैट इज एक्चुअली नॉट इवन इंपॉर्टेंट इन एनी केस, राइट. सो जो सेल है इसका जस्ट ई अपॉन टू काम कर रहा है, सो दिस इज एक्चुअली जस्ट ई अपॉन टू और इसका ई आर है. गॉड. सो ये जो वायर रहेगी उसकी लेंथ क्या रहेगी, राइट. तो या सो E upon 2 is equal to E upon R plus 1 meter, and that times AG की length is called as L. So yeah, ये ratio रहेगा, I mean current voltage drops का, right? Okay, that's the thing. The resistance है, do we even know what that? Okay, we actually don't know. Shit. Okay, this is getting complicated. We'll say this thing. So R plus जो भी resistance इसका होगा, okay, internal resistance 2R इसका है. पोटेंशियोमीटर वायर का रेजिस्टेंस क्या है? पोटेंशियोमीटर वायर इज 100 सेंटीमीटर लॉन्ग. हाँ बट उसका रेजिस्टेंस कितना है? पोटेंशियोमीटर वायर इज लॉन्ग. कुछ भी दिया नहीं इसमें, राइट. लेट्स जस्ट से रेजिस्टिविटी नहीं बोल सकते उसको. रेजिस्टेंस पर यूनिट लेंथ लैम्डा है, सो इट्स लाइक लैम्डा टाइम्स 1, दैट्स द रेजिस्टेंस और समथिंग. और यहाँ पे रहेगा जैसे कि कैपिटल आर बोल दो ना, रेजिस्टेंस ऑफ द थिंग. फिर यहाँ पे जस्ट एल आ जाएगा, राइट. Well, yeah. So that's the thing. Okay. So if the balance is obtained, the length AJ equal to L. God. So L is bigger than R upon 2, right? Shit, यहाँ पे LR चाहिए था, sorry. Yeah. Okay, so L is bigger than R upon, like L is bigger than 1 upon 2 meters. So L is bigger than 50 centimeters. So B is right. Balance will obtain only if the resistance AB is bigger than R. AB is bigger than R. कौन सा ये वाला R? Okay. So capital R should be bigger than R. That's what you're saying, right? Oh yeah. Okay, understood. तुम क्या कर रहे हो? So basically like ऐसा हो जाएगा, L is equal to R upon R plus 1 upon 2. तो ये चीज़ जो है दैट हैज़ टू बी लेस देन 1, अदरवाइज कहाँ पे जॉकी तुम रखोगे. सो दैट मीन्स कि R upon R is less than 1 as well. So like R has to be right. Understood. So yes, C is correct, D is correct. Balance cannot be obtained. D and C. Next question. 81. 81 is two heaters designed for same voltage V. Sorry. Okay. Different power ratings when connected individually across a source of voltage if they produce H amount of heat in time T1 and T2. When used together across the same source, they produce H amount of heat in time T. अच्छा. Individually across a source of V produce H in T1. तो power जो रहेगी is like V times I. Just V square upon R बोल दो ना. Okay, let's call this like 1 and 2 resistance heaters. क्या बोला सेम वोल्टेज V यूज करना है इसको. इसका रेजिस्टेंस अपन R1 बोल देंगे. देखो पता नहीं R1 is to R2 क्या होने वाला है, बट जो भी है. Since our resistance is कि तुम्हारा power है that's like H upon T1 is to H upon T2, so it's like okay, so ठीक है ना, power is H upon T1 and H upon T2 जो भी है, which is also just I square, which is in the ratio T2 is to T1 I believe. So T2 is to T1 ratio my power, which is like V square upon R is in this ratio, right? So actually resistance is okay. Wait, and power is also like V square upon R, which means 1 upon R1 is to 1 upon R2. This ratio is the same as that one. R1 is to R2 ratio is like the same as T1 is to T2. Okay. तो उनका रेजिस्टेंस जो है those are in ratio T1 is to T2. That's what we got. Okay, अपने को निकालना क्या है वैसे. So first केस में पावर ऐसी है and जब तुम इनको साथ में कनेक्ट कर डालोगे, right? When used together across the same source, तो उनकी पावर क्या रहेगी? Yes, there's a difference. Okay, that's not going to work. अपने को एक्चुअली वैल्यूज ढूंढनी पड़ेगी. ठीक है ना, नो बिग डील. Just have to figure out the values. So, पहले की पावर क्या है? V square upon R1 is equal to H upon T1. So R1 is just equal to H upon T1 V square. Similarly, R2 is equal to H upon T2 V square. अपने को निकालना क्या है? You want to figure out and across the same source to produce H amount of heat in time T. So H upon T is the new power, which is once again just V square upon R, but then yeah, just V square upon R1 plus R2, which is like H upon T1 V square, and then just have it's not a big thing, right? Actually गड़बड़ कर रहा हूँ. Oh, this is 1 upon R. Sorry. Okay, so R1 is like what, T1 V squared upon H actually. So क्या जगह पे T1 plus T2 times V square upon H. तो just yeah. So T equal to T1 plus T2 in that case. So A is answer, and if they are in series, it's this thing. Oh yeah, that is what I got. So A is correct. और क्या, if they are in parallel, तो जो resistance आएगा, it's right. So in time T they are producing H. So ठीक है. H upon T is the total power, which is actually power from one of them, power from other one. So इनका like addition basically. So H upon T1 plus H upon T2, because वो like these are the powers of these guys. So add कर दिया, right? Yes. So हाँ, if they are in parallel, it's going to be what, T1 T2 upon T1 plus T2. So C is the answer. Okay. Next question, 82. 82 is okay. A small magnet M is allowed to fall through a fixed horizontal conducting ring R. Let G be the acceleration due to gravity. The acceleration of M will be magnet को okay fall through a fixed conducting ring R. G next. Okay, the acceleration of M will be, so like it will retard this, right? Yeah, so less than G when it is above R and moving towards R. Oh yeah, and it's bigger than G. Wait, something's wrong. What? So जब तक ये आ रहा है, it's like it's retarding, and then जब ये निकल रहा है, now suddenly it is not letting it go, right? Yeah. Wait a second. It's like जब yeah, it's like north south जैसा कुछ भी create हो गया इसमें. So first it's opposing. अब ये कैसा हो गया, south south आ जाएगी. Okay, cool. Then it's letting it not letting go. So it's less than G both times. So wait, अच्छा अलग अलग किसी. Okay, less than G when it's above and moving towards R, then it's less than G. Yes, understood. When it is above and moving towards R, wait, same ही तो है. Okay, when it's below R and moving away from R, दोनों में okay, it's still less than G. So A is correct and C is correct. 83. 83 is in the previous question, the direction of the current flow in the ring where M is above R and below R will be. So it depends तुमने मैग्नेट को कैसे पकड़ा हुआ है, ये नॉर्थ है कि साउथ है कि हो क्या रहा है, ये बताओ एटलीस्ट. Okay, direction of the current flow in the ring when M is above R and below R will be. Oh, okay, समझा. So it's the same. Current still same रहेगा because discontinuity नहीं हो सकती. So it will be same. Yeah. Same in all cases. Wait, what do you mean by all cases? I guess it should be the same in all cases, right? So yeah, A is the answer. 84. Okay, the magnetic flux linked with coil is phi and the magnetic induct. और ये क्या है? Saying only if north pole of M moves towards R when M is above R. So yeah, okay, so M basically move towards R when M is above R. Then okay, क्या तुमने ऐसा कोई भी केस देखा है जहाँ पे ये अपन ऊपर खींच रहे जब ये ऊपर है ऑलरेडी? नो, राइट? तो वॉट एवर, नेक्स्ट क्वेश्चन. 84 हो गया. सेम कौन से केसेस, ये तो बताओ एटलीस्ट. आई हैव नो आइडिया. इसलिए अजीब और 83 में वोकेबलरी इनकी सही नहीं है. मैग्नेटिक फ्लक्स लिंक्ड विद द कॉइल इज phi, then the EMF induces E. In it is E. If phi equal to 0, E must be 0. That's wrong. Because d phi upon dt में रहता है. Okay, if E is not 0, phi may or may not be 0. हाँ ना, E is not 0, phi can still be 0 or it cannot be 0. दोनों चलता है. So C is correct. और क्या है, phi is not equal to 0, E cannot be 0. नहीं, E still 0 हो सकता है. phi को तुम बस कांस्टेंट रख दो. None of the option is correct. Okay, C is correct at least. Next, 85. 85 क्या है ये? A square loop ABCD of HA moves to the right with velocity v parallel to AB. AB is this. What is this? Okay, fine. There is a uniform magnetic field of magnitude 3 directed into the paper in the region between PQ and RS only. 1, 2, 3 are the position of the loop. EMF induced in loop has magnitude BAB in all three positions. Okay, इस position में क्या हो रहा है? Well, yeah, it's BAB in this position. इसमें 0 है. And in this case it's still BAB. Okay, so no, not on all three positions. Yeah, induced EMF is 0 in position 2. Yes, the induced EMF is anti-clockwise in position 1. I think EMF तुम पूरे loop में ले रहे हो, right? कुछ बोला तो है नहीं, ठीक है जो भी है. The induced EMF is 0 in position 2. Yes, the induced EMF in clockwise in position 1. It's clockwise in position. What? Anti-clockwise. So magnetic field कहाँ पे जा रही है? It's going into the plane, right? Right, into the paper. Okay, cool. तो तुम ये increase कर रहे हो, like so you have to, yeah, okay. So it is in fact anti-clockwise in first case. Okay, so anti-clockwise in position 1, yes, and it is clockwise in position 3. So C is correct, D is correct. Yeah. Okay, 86. In the previous question, in position 1 of the loop, the induced EMF will increase linearly as the loop enters the field. No, अगर तुम्हारी V constant है, then no. Okay. Induced EMF will increase linearly as the loop enters. No, so A is wrong. The induced EMF will increase from 0 to BAB sharply as the edge BC crosses. BC कौन सी edge है? कुछ भी. हाँ, पोजीशन 1 ऑफ द लूप, इट शुड बी BD. चलो ठीक है, आई थिंक उन लोगों ने शायद से ये, ओह ओके, इन लोगों ने C और D चेंज कर दिया लगता है गलती से. दिस शुड हैव बीन C एंड दिस शुड हैव बीन D, जो भी है. ओके, so it will sharply increase. Yes, okay, so probably B is correct. PQ, okay, cool. The induced EMF will have a constant value B A square V. Yes, the loop will experience a force to the left after entering the field partially. Wait, what? A force to the left after entering. So the current है, it's going in anti-clockwise direction, and then right. Just like the right, it's going from there to there, right? That's our displacement, which is BLV, or I should say, it's like V cross B. So okay, cool. Just I L vector cross B vector. Current is going in this direction, so L vector is actually in this direction, so upward, and then B vector is in downwards. L cross B is, yes, it's in the left direction. So yes, look will express a force to left. So D is correct. C is also correct. So increase from 0 to B A B sharply. A square कैसे आ गया इसमें कुछ भी नहीं? That's not right. It should be BAV. Okay, so C is probably not correct. So C is not correct in that case. D is correct though. I think B is correct, but यहाँ पे B D चाहिए, जो भी है. B and D. Next question. 87. क्या ये conducting disk radius r spins about axis with an angular velocity omega, uniform magnetic field of magnitude p perpendicular to plane of its okay c center of disk, no EMF is induced in the disk. पूरे डिस्क एक बात बताओ यार तुम्हें, you need a path, not a complete surface for EMF. But ठीक है, I think there is no EMF induced in disk. Right, because समझ electrons है, those actually not moving. You can say there's induced EMF as well as there's EMF because जो charges है वो distribute हुए in a way. So I don't know क्या बोलूँ. What is the difference between C and so potential difference, right? तो जो अपन conservative forces अपन सिर्फ उनको ही गिनने वाले हैं. We don't want the magnetic field को जैसे change हो रहा है. Okay, potential difference between C and the rim is half p r squared omega. Wait, think about it. Half p r squared omega between C and the rim, of course. Like V cross B is our okay, in this direction, but if the negative is फर्क नहीं पड़ता, we'll just consider positive test charge, so it's pointing in this direction. Okay, and then you need a centripetal force. जैसे कि तुम क्या बोल रहे हो that B times V कितना होगा इस केस में, just r omega, but that's the charge, so एक इलेक्ट्रॉन का potential E B R V, right? इलेक्ट्रॉन नहीं, अपन एक let's take a proton. I know अजीब है, but whatever. You should probably take an electron though, right? Because electrons are the one carrying the charge, right? Conducting this bola. So negative EBRV towards the center in that case. God. Okay. This is equal. Okay. और क्या है? और क्या center क्या लगाऊं? Also the field. So अपन assume कर रहे हैं that field is going like okay from C to the rim. So field is radially outward, then it's just minus EE in the radially inward direction in that case, right? No, radially inward direction. Okay, it should be plus EE in the radial. Wait a second. B inside has to. अब देखो radial inward ही तो चाहिए. So radially inward क्या रहेगा? It's just just plus EE, and this is equal to m mass of electron omega square r. That's our equation. Okay, इसमें क्या 9 times 10 power negative 31 आता है, and then E is like 16 times 10 power negative 20, तो फिर ये this is a very less than this I assume. तो इसका मतलब हुआ कि this is approximately like 0. इसको हटा दो. Please get this thing that E is approximately equal to BRV, sorry BR omega, right? So integrate that, just get like half PR squared upon 2 omega. That's the potential difference between C and the rim. So B is correct. Okay, और क्या है? C is at higher potential than the rim. Yes, because field is going from there to here. That's what we assumed. So yes, this is right. Current flows between C and the rim. C and the rim. No, because वो steady state है, अपन ने already assume किया है. Okay, this is getting weird. No EMF is induced in the disk. There is an EMF, right? Because right, so there is an EMF, even including the induced EMF, right? So not just magnetic field की वजह से जो हो रहा है, but also because of electric field. वो दोनों combine. that combined there's an EMF from C to the rim, right? Current flow नहीं हो रहा है, but there is an EMF. Current क्योंकि ये rotating है ना, so that force, centrifugal force, is also taken into account. So yes, you need A in there. But wait, centrifugal force वाला ये part है, but that's negligible. We already said. So there is no EMF in that case. God, this is not going good. In steady state यहाँ पे कोई EMF रहेगा ही नहीं, because the electrons won't flow anywhere. That's what we are assuming. So then what do we do now? If that's the case, okay, then A correct नहीं, फिर B is correct and C is correct, and what current flows between C and the rim, that's not incorrect. So B is correct and C is correct. Next question, 88. 88 is a flat coil C of n turns, area A and resistance R is placed in uniform field of magnitude B. The plane of the coil is initially perpendicular to B. If the coil is rotated by an angle theta about axis XY, charge of amount Q flows through it. Flat coil C n turns, इसमें n turns है, okay, जो भी है. Resistance R placed in uniform magnetic field of magnitude B. Okay. The plane of the coil is initially perpendicular to B. Okay. If the coil is rotated by an angle theta about the axis, charge of amount Q flows through. It's like क्या होता है, like just d flux upon dt is our potential, which is also just R times I, right? So just R times dq upon dt, which means that delta phi is equal to R delta q, right? Oh yeah. Okay, if the cell is rotated, coil is rotated by angle theta about the axis xy. तो initially तुम्हारा जो flux था, that was just area times, well, yeah, okay, and then अब तुम्हारा change हो गया, बस वो magnetic field is at some angle. Our area vector is in this direction, so it's directed by angle theta, or yeah, just say this is our area vector actually. Then this is angle theta, right? So जो तुम्हारा dot product रहेगा, right? Dot product रहेगा, so cosine theta आ जाएगा basically. So what do you get? The charge that went through it, कितना होगा? Just magnetic field times area just like pi r squared, but actually n times because हर loop का तुम्हें देखना पड़ेगा. Okay, and that times initially हमारा 1 था and minus cosine of theta. Yeah, that's the thing. That's equal to r delta q. So rq in this case, because yeah. So हमारा q रहेगा, this is just equal to pi r squared, like n जो भी है, q is proportional to 1 minus cosine theta. Just figure out the thing. So I guess I should just write down the expression. Q is equal to n. Oh, this is not resistance by the way. This is like the radius of the thing. So अच्छा area ये तुमने दिया है, then why even do all of that? Just EA. So n AB upon r times 1 minus cosine theta. That's our answer. Okay. So if theta equal to 180 degree, it's just 2n. ये तो नहीं है इसमें. Theta equal to 360 degree, n equal to z. Sorry, q equal to 0. Yes. Theta equal to 90 degree, q equal to ये चीज. Yeah. Okay. So A is right, and 180 q equal to 0. That's also wrong. So A is correct and D is correct. Next question. 89. 89 is in the previous question. The plane of the coil is initially kept parallel to B. All other details remain the same. Uh, okay, seriously. So initially तुम्हारा कितना था फिर? 0 you are saying, right? Okay, so like cosine of theta, just that. Wait, अब नहीं, अब sin of theta आएगा because you are now having, right? So ये तुम्हारा area vector is in this direction. This is our magnetic field vector. अब तुमने इसको change किया है by let's just say theta. So you want cosine of this angle, like sin of theta basically, right? So now this will be the thing. So तुम्हें क्या चाहिए? If theta equal to 90 degree, oh फिर 89 का मैंने क्या किया था सर? नहीं 88 का किया था ना, A and D. Right. So if theta equal to 90 degree, then oh shit. So हमारा जो wait, rotate by angle. Okay, no, it's good. It's good. So yes, Q equal to B A N upon R. Yes, that is right. So A is correct. और क्या है? 180 degree पे 0 हो जाएगा. It's not the thing. 6 degree पे 0 हो जाएगा. Yes. So C is correct, D is correct, A is correct. Next question. 90. 90 is two parallel resistance less rails are connected by an inductor of inductor L at one end as shown in the figure. A magnetic field B exists in the space which is perpendicular to the plane of the rails. Now, wait, okay, what? Perpendicular plane of the rails. Okay, cool. Two parallel resistance less rails. अच्छा ये चीज okay cool. Okay, L mass M is transverse of the given impulse J towards the right direction. Then choose the correct options. Velocity of the conductor is half of the right. Just have to do it correctly. Fine. So suppose at some instant for B se ja raha hai, right? Then just have BL. V is our EMF induced. This is equal to L di upon dt. Okay, should we just say magnetic field कहाँ पर भी है? This is the EMF that is actually causing this thing. So आपको potential drop चाहिए. Current is supposed to be increasing, right? So yeah, you are putting more energy into it. That is the thing, of course. Right? वो जो EMF cause कर रहा है वही EMF वापस वापस वही पे आ रहा है, right? So yeah, it's actually DL, DI quantity increasing, of course. Yeah, that's the thing. Okay, so this is okay. And जो force लगने वाला है on this thing, that is what? The force is just so current है, it's actually so we know it's supposed to be retarding this because वो नहीं चाहता कि कुछ हो. So retarding force रहेगा and it's like just what? Negative क्या करना है इसमें? Oh yeah, just the current. Okay, negative I that times magnetic field that times the length. So just L itself. Yeah, this is the thing. So force is just that, which means like dV upon dt is equal to what? Negative I B upon M times L. Yeah, right. Or like I should say BL upon M times I or whatever. So अगर मैं इसको डिफरेंशिएट करता हूँ, what do you get? It's like d squared v upon dt square is equal to, and अब देखो सब कुछ ढूंढना क्या है? Velocity of the conductor, current also you have to figure out. Oof. So you got this expression, using that you can figure out the current or something, and इसको तो मैं डिफरेंशिएट कर सकता like d squared v upon dt square is equal to negative bl upon m times di upon dt, but we know what di upon dt is just blv upon L, right? So what you get just v double dot मतलब कि dv upon dt, that stuff, that is equal to what? So ये क्या है? Just negative p squared L squared upon m times L times v, right? So basically v is equal to amplitude sine. I get it. A sine in this case like v naught, जो भी initial उसको दिया था, because initial हमारा current zero था ना, so our dv upon dt was zero, which is like yeah, you get the thing. Sine initial हमारा phi जो रहेगा is like pi upon 2. Yes, pi upon 2, and then it's like decreasing. That's why cosine जो रहेगा it's getting complicated. Probably we should just put cosine over there. Yes, just cosine of omega t. And omega is this का square root like PL upon square root of ML and that times of t, right? Well, yeah. So at t equal to 0, just have v equal to v naught, and then also got what current should be. जो भी है. Like yeah, sine आएगा and then वो 0 है, it works out. Right, and then dv upon dt by itself is like 0. And यहाँ पे negative आने वाला है, and then as t increases, it will try to retard this, right? Okay, I guess this is the thing. This must be the thing. So you got the expression. अब हमें करना क्या है? Also using this, you can figure out what the current should be, just negative. Oh god. So negative dv upon dt, okay, negative m upon bl times dv upon dt, which is वो negative पॉजिटिव हो जाएगा, just v naught sin आएगा इसमें, just bl upon square root of ml भी आने वाला है. Then you got sine of omega t. So ये गया is just this thing. Square root of m upon L times v naught, and then just have sine of omega t, which is this thing bl upon square root of ml times t. This is our current, capital H inductance. So you got current and you also got v. Ready to go. Chalo, using this you can figure out everything, I guess. Oh, it should be m over there. It's for delete क्यों डाला? Okay. So क्या करना है अपने को? We want to figure out velocity of the conductor. Okay, conductor is half of the initial velocity after displacement of this thing. Also, the conductor is half of the initial velocity. Displacement, seriously. Okay, this is not going good. तो डिस्प्लेसमेंट ढूंढनी पड़ेगी ना कि x इज इक्वल टू x नॉट फिर यहाँ पे साइन आएगा इन दैट केस राइट एंड यू नो व्हाट x नॉट इज we just v naught upon x is equal to v naught upon omega so यहाँ पे जाएगा v naught square root of ml inductance not that वाला l upon bl that's the thing right नीचे l आया था ये was d upon dt में that was the thing I remember it this is this thing v naught upon omega and like sin आएगा तो sin bl upon square root of ml times t जो भी है that's our expression अपने करना क्या है the velocity of the conductor is half of the initial velocity after displacement of the conductor t equal to this उसमें स्क्वायर रूट में डालने वाले हो दैट्स नॉट गोइंग गुड सो क्या जगह पे लाइक नीचे b स्क्वायर l स्क्वायर आ रहा है राइट v नॉट इज लाइक j अपॉन m तो इसलिए यहाँ पे m आया यहाँ पे j स्क्वायर आ गया फिर वो m l तो यहाँ पे रहता ही है सो यहाँ पे 3/4 है बेसिकली उतना ही स्क्वायर ऑफ 3/2 सो sin phi is like sort of 3/2 so cosine will just be like 1/2 that explains it so yes a is correct और क्या है current flowing through the inductor at an instant when the velocity of conductor is half of the initial velocity so अपन निकाल चुके हैं that sin ये जो भी है like square root of 3/2 is just that thing so square root of क्या 3/4 that times of ml v naught square is like j square upon m square in that case so just square root of 3j squared upon 4ml in that case, right? But yeah, so B is also correct. Velocity of the conductor is half of the initial velocity after displacement of the conductor d equal to this. 4 है नहीं, so that's why it's not a thing. Current, once again same stuff. It's 4 नहीं दिया है. This is it. This is our equation in that case. Okay, next question. Yeah, इतना क्या सोचना है this is our equations okay next 91 wait actually you know what no we should stop here because 1 घंटा हो गया almost okay then I'll see you guys next video